So I'd better move on to introduce Professor Philippe Sansonetti, who is Director of Molecular Microbial Pathogenesis at the Institut Pasteur. And his topic is innovative technology. But Professor Sansonetti's background is very much in diarrheal disease, which actually is a neglected disease in the sense that it's still the second leading cause of death in children under the age of 5. And this is really an unacceptable situation. And not only does it cause death, but it also causes severe malnutrition and therefore susceptibility to other infections. So although access to clean drinking water and adequate sanitation are obviously part of the solution, I'd like to ask Professor Sansonetti, what else should we be doing to address this enormous health problem, and what innovative technologies do you see that should be employed?
Well, thank you, Alan, for asking this question. I know that diarrheal disease is not necessarily on the radar screen of organizations, institutions, companies. For one reason, it's the diverse disease syndrome, which is linked to many different microorganisms. Therefore, it has made our life difficult in terms of developing a single vaccine, a single drug that would take care of this. Just in a few words to try to say, we need to focus. We need to give a clear view of the situation if we want to move forward. So the first point is that mortality has decreased down to 2 million. That's still a lot, but it has decreased by 50% in about 20 years. And this is oral rehydration therapy, which was probably the big revolution, and we are still looking for another revolution like this in the field. On the other hand, as mortality has decreased, and this is also linked to education of mothers, morbidity remains the same. It has even increased in some areas, and this has all to do with the new poverty in different places and so on and so forth. So we are still dealing with a disease that has a huge impact in public health, and we really need to think about this. So how can we focus our efforts better? I think a very concrete example is a recent study that was coordinated by Mike Levine in Baltimore, that was funded by the Gates Foundation. It's called the GEMS study. And what they have looked for in the most impoverished areas is, well, what are the major etiology of diarrheal diseases? And they came up with 4 species, 4 different microorganisms. So that's a way to focus. Rotavirus, of course, dominates the field. It might decrease with the vaccination, but still there around. Shigella, what's called enterotoxigenic E. coli, especially one particular pathotype which produces a small molecule which is called the ST toxin, and a sort of emerging microorganisms which is Cryptosporidium. So now we have the landscape, and I think this is very essential to update these epidemiological studies if we want to see the field of diarrheal disease moving, because it is a moving field. And the last point, which is very important, is that as mortality has decreased and morbidity continues to be the same, we are seeing a new angle of diarrheal diseases, which is already mentioned, which is chronicity, relapse, and malnutrition. And this has to do with this now, what's called the pediatric environmental enteropathy, which is that after several boosts of enteric infection, these kids have bacterial overgrowth in their gut, they have bizarre immune response at the mucosal level, they have problems in epithelial repair processes. So all these are new angles of diarrheal diseases, which is I would say, the modern aspect of diarrheal disease. So we have to leave the old paradigms and get into the new paradigms. And this might be offering new opportunities. So where are the opportunities? Opportunities is in diagnostic. Now we really need to update these epidemiological data, and we also need to have tools in the field to be able very quickly to say, this is a viral diarrheal disease, needs usual rehydration therapy, no need for antibiotics, for instance, or any new molecule. But we also need tools to be able, again, to upgrade these epidemiological studies. point of care is clearly, to me and to us in general, the answer. I mean, we cannot go with the complicated, complex, long-term microbiology, and the setting is not there, too expensive and so on and so forth. So we need tools. For instance, Institut Pasteur and Médecins Sans Frontières Epicentre, we've launched a program and a call for application for people to develop these kind of point-of-care tools. I think, as has been mentioned already, we have the knowledge. I mean, we have pangenomics libraries for Shigella, for instance, for Escherichia coli, probably very soon for Cryptosporidia. We have immunochromatography. We have new PCR technology, like the LAMP technology, that are robust enough, don't need change in temperatures, that they can be used on the field. So we are asking the community to get together, possibly also applying microfluidic and all these ways to sort of compact the test, to respond to these calls and provide some innovative views on the diagnostic. So that's the diagnostic. Therapeutics, also, there are opportunities, especially, again, if you look under the angle of these big four, as I said. We know a lot over the years on the pathogenesis. This is offering possible targets. We know how Shigella invades the gut. We know how these toxins from ETEC are actually causing activation of guanylate cyclase. There is room for pharmacology. We know how the Cryptosporidium is embedding itself under the apical membrane of intestinal epithelial cells. There are effectors for this. Some of them needs to be identified. So I think basic science is now offering opportunities, even though, again, there is a diversity that remains. And maybe we can keep the vaccine for another question.
Yes, thank you. You've covered several points that I wanted to raise very well, actually. But yes, let's ask about the need for new vaccines. You've mentioned rotavirus. You've mentioned Shigella, pathogenesis type vaccines as well.
Yeah.
Where would you put the priorities for the future?
I think it's complicated. There has been one success story, and we needed this success story. It's the rotavirus vaccine. Problem with the rotavirus vaccine now is that we are starting to discover some of its limitation in the most impoverished areas. Again, probably largely because of this environmental enteropathy, the gut. I mean, the vaccine shows poor catch on these kids because they just goes there and passes off. So there are issues there which needs to be reconsidered, which are sort of generic issues. The field is moving more and more towards parenteral vaccination against diarrheal diseases. There are examples showing that it may work in the case of Shigella, in the case of ETEC, for instance. Cryptosporidium, there is no example yet. But there is still a window that is essential, which is not efficiently targeted by this parenteral vaccine, which is very young kid between birth and the age of 2 or 3 years. There is something in their immunological system that makes difficult to set up a parenteral and systemic response which is diffused out in the gut in sufficient level to be protective. So here we need major basic research in mucosal immunology to be able to solve these issues.
Very young, yeah.
Okay.
Okay.
Sorry.
Yeah, I think I'd better move on. Otherwise, we won't get round to questions from the audience. I appreciate the comments there.